Good afternoon, everyone. Welcome to our webinar. Before we get started, I have a few procedures to go over. Please, everyone, mute your line, and you can ask the chat box to ask any questions you may have, and we'll be answering all the questions at the end of the webinar. For any additional questions you may have, you can email them to education@nola.gov, and there are no CEUs offered for this webinar, but we will be posting it to our YouTube channel, which you can search by just searching New Orleans Mosquito Control. Now I'll turn it over to Aaron, who will be introducing today's speaker.
Good afternoon. So today we have with us Dr. Janis Reed, board certified entomologist. Dr. Reed is the Director of Product Development and Regulatory Control Solutions Incorporated. Janis brings with her more than 20 years of experience, including more than a decade with a large independently owned pest management company as the staff entomologist and technical director. Other roles include several years of research and pesticide education experience. Janis completed a Bachelor of Science, a Master of Science, and her PhD in entomology, all at Texas A&M University, with a focus in urban entomology. Her research and interests include social insects, especially ants, as well as foraging and feeding preferences of insects. Janis holds and maintains her accreditation as a board-certified entomologist, and has been a licensed structural pesticide applicator since 2000 in pest control, termite control, lawn and ornamental pest control, and weed control. In her role with Control Solutions Incorporated, Janis oversees all operations, functions, and activities related to projects as they move through the various stages of product development up to and including launch. I myself have worked with Janis and Control Solutions in the past, so it is my pleasure to introduce her to you all. Dr. Janis Reed, you have the floor. Thank you.
Thank you, Erin. It's always good to talk to you, and especially the folks at NOLA. Thank you for hosting this webinar today. I'm very excited to be here. Very excited to be able to talk about this topic, which I am somewhat passionate about. So we're going to go ahead and jump in. And the topic of today's webinar is arrested development, and that's kind of my kitschy little title for it. But the goal here is at the end of it is for you to understand how IGRs work and how they can work for you as a PMP. So let's kind of talk about what we're going to cover today. So we're going to talk about what are IGRs, a little history on insect growth regulators, how they work, and because we're going to get into how IGRs work, we have to talk a little bit about insect development. I'm going to keep it very surface, but we do have to get into it. We're going to talk about the IGRs that are commonly used in structural pest control, a little bit on IGRs and bed bugs, common misconceptions. We'll talk a little bit about IGRs and mosquito barrier sprays and my experience with that, a little bit of caution and drawbacks using IGRs for pest control, and then finally we'll talk about how to choose the right IGR for structural pest control. So the first thing I want to kind of get settled is what exactly an IGR is. So we in this industry talk about IGRs as an insecticide that regulates growth, but not all insecticides that are classified as IGRs actually do that. So for example, chitin synthesis inhibitors are not involved with that development process that we typically think of as a growth regulator. There was a researcher in 2005 who actually coined the term insect growth disruptor. And so for today's seminar, I'm actually going to use the term IGD and IGRs somewhat interchangeably, but IGD really is the more correct term because it's more encompassing of the entire group as a whole. And I'll explain more about that as we go along. So what exactly do I consider the insect group growth disruptors. So this is a group of chemicals that disrupts the normal life cycle of an insect. So we all know eggs go through several 3 or 4 stages in development. Egg, larvae, pupae, adult, if you have complete metamorphosis, egg, larvae, adult, if you have gradual metamorphosis. So these groups of chemicals can affect each of these life stages differently. It can prevent egg hatch, it can stop molting, it can inhibit the ability of the insects to grow or develop naturally, it can inhibit reproduction. So all of these stages can be impacted a little differently by the different insect growth disruptors, with the ultimate goal of, if an insect can't reach adulthood, it can't reproduce. If an insect can't reproduce, it can't add to the overall population growth of that pest population. The thing about IGDs, and I think we need to kind of keep this in mind as we go through this entire seminar, is that these insecticides, and I'm putting that in air quotes, are rarely toxic to adult insects. Usually, adult insects exposed to IGDs live a fairly normal lifespan. So they go on about their merry way, maybe only being affected by not being able to lay a normal clutch of eggs, or maybe those eggs don't develop, or something along those lines. But remember, that actual adult, really not a lot of effects if it makes it to that adult stage. So that begs the question, are IGDs actually insecticides? And I answer that with yes, but however, because they don't act on the muscle or the nervous system, they don't provide that quick kill that we're used to seeing with modern insecticides. What I mean by that is other adulticides that we commonly use for our work. So all of your pyrethroids, so bifenthrin, lambda-cyhalothrin, gamma-cyhalothrin, all of the thrins, all of your pyrethroids, fipronil, neonicotinoids, indoxacarb, these are all adulticides. And while one of those or a couple of those might be slow acting, they're still going to provide a quick relative kill of an adult insect. IGDs, however, work very differently because they're disrupting important insect-specific growth functions. And what does that mean? It really depends on the IGD that you're talking about. Another thing that we need to kind of keep in mind is that insect growth disruptors are often mixed with other adulticides or other insecticides and applied as one application. Generally, these active ingredients are considered softer on humans and other mammals than conventional insecticides, and they're usually lower in toxicity. Because of that, they get this indication of low impact. And you'll see a lot of recommendation to use IGDs, IGRs in things like school IPM programs because people don't molt, right? So they're viewed as softer, but these still are synthetic chemistries that we're applying to manage pests. So why do PMPs choose to use IGDs? So I think there's a couple of different reasons. So the first is that most conventional insecticides act pretty similarly. They work on the insect's nerve or muscles, and it kills the insect in that way. IGRs, as I mentioned, are often mixed with these adulticides to kill the adult pests. And then perhaps if there is some resistance, let's say, there is an IGD or an IGR there to clean up or control any of the developing insects that the adulticide doesn't kill. Some insecticides even affect mammals in ways similar to arthropods. Now, a lot of these active ingredients are being slowly removed from our cache of products that we can choose from, but there are insecticides that affect mammals the same way that they affect the insect pests that we're trying to control. So these IGDs, because they are very specific to insects and arthropods, typically have target sites that don't exist at all in mammals and are selectively toxic, are considered a good choice for a lot of structural pest control applicators. So that brings us to the question, how do these chemicals regulate or disrupt growth? So in order to understand how IGDs work, we really have to kind of take a step back and understand, at least basically, how insects grow and develop through their life stages. So they do this with the help of natural hormones and growth processes as they move through each of those life stages: egg, larva, pupa, adult. So let's walk through a kind of normal development stages of an insect. So there are several hormones that play an important role in the development process of insects. Brain hormone, molting hormone, and juvenile hormone are three very important hormones that key different things as we move through those developmental process. So the first one we're going to talk about is the brain hormone. So brain hormone is released when the insect needs to molt into a larger exoskeleton. It has outgrown the exoskeleton that it's in. The brain then secretes the brain hormone, and this hormone then triggers a chain reaction that starts the process of metamorphosis. Brain hormone itself triggers glands in the prothorax, so the first segment of the thorax, to produce molting hormone. So again, this is kind of a dominoes falling, and brain hormone being secreted is one of the first dominoes that falls. So glands in the prothorax have created molting hormone, and molting hormone is produced in many cells in the insect's body, and that is responding to that molting hormone. Ultimately, this is going to cause a new exoskeleton to form under the old exoskeleton. So we all talk about the molting process and seeing a newly emerged insect and how they aren't fully hardened yet. Like when I remember when I first got into entomology, I was described an albino cockroach, but truly that's just a freshly molted cockroach that hasn't completely tanned its exoskeleton, hasn't completely hardened its exoskeleton. So as that interior, that second exoskeleton is formed, that insect has 2 layers of exoskeleton, and it needs to shed that old one in order to allow that second layer to fully expand. Imagine like a tent folding out of a bag. It unfolds and hardens into a larger body. Now the picture you see over here on the right is a little grasshopper, and you can see he or she, can't tell which one, has pulled itself out of that old exoskeleton that's been left behind. So the new one that he's formed, is larger than the exoskeleton that they just left. All right, so then we have juvenile hormone. Now, juvenile hormone is produced by the brain before each molt, and it's an important regulator of insect growth and development. We're going to talk a lot about juvenile hormone as we move through this presentation. So juvenile hormone, when the levels are high, stops development of adult characteristics, such as wings, reproductive organs, and external genitalia. So when those levels are high, the insect remains an immature form, whether that be a larvae or a nymph. And then if JHAS levels drop, wings, eggs and sperm production, reproduction, maturation, that ready to molt to the adult form begins to occur. As an aside, juvenile hormone also plays an important role in caste differentiation. So for example, termites, if you have high JH levels in workers, they're more likely to become soldiers. So again, juvenile hormone is a really important hormone to insect development to adulthood. So remember juvenile hormone. So the next thing we're going to kind of talk about is insect growth disruptors and which ones we use in structural pest management. We have 3 groups of IGDs that are commonly used in structural pest management. Juvenile hormone mimics, which belong to IRAC Group 7, chitin synthesis inhibitors, which belong to IRAC Groups 15 and 16, and ecdysone receptor agonists, which belong to IRAC Group 18. How do we identify what IRAC group the product you're using belongs to? There's 2 different ways you can do this. In some labels of some manufacturers, they're actually including the IRAC group on the front of the label. So in this example, you can see there are 3 IRAC groups represented in a single product: Group 3, Group 15, and Group 7. If for some reason it's not explicitly listed on the label, you can always go to IRAC online and look up what IRAC group the product that you are working with fits into. For example, maybe a chitin synthesis inhibitor, maybe a juvenile hormone mimic, and you can look on that website and see exactly what IRAC group you're using to manage insects. So let's give you some examples of each of those groups. So over in the juvenile hormone mimic side, we have pyriproxyfen, hydroprene, methoprene, and phenoxycarb. And this is not a complete list, just examples. Chitin synthesis inhibitors, a few examples are novaluron, novaflumaron, and diflubenzuron. And then ecdysone receptor agonists include tebufenicide, methoxyfenicide, and halofenicide. So those are the common IGDs that we see in our work in structural pest management. Now, I want to kind of take a pause here for a minute and switch gears a little bit, because I want to talk a little bit about where IGDs came from. How did we land on the idea of using the insect's own biochemistry against it, its own development against it? So this idea is not a new one. It's been around a while. As early as 1956, juvenile hormone was isolated from a moth larvae and later applied to another moth larvae, which then prevented that larvae from molting and metamorphosizing into an adult moth. A very, very common story we hear in entomology is the paper factor story, and this occurred in 1965. Cultures of linden bugs were showing low egg hatch rates, adults weren't forming naturally, and they were in culture in a lab, and these were insects that had been cultured in labs for years in other places. But what it turned out was that paper towels from the rearing jars were made from balsam fir. And this released vapors of a substance that actually affected the developing insects. This substance was later identified as containing juvabione, which is a juvenile hormone mimic that specifically affects true bugs in this particular family, in the linden bug family. And this really led to more industrial interests of using juvenile hormone as a tool to combat insects as pests. So again, we had kind of thought about this idea in 1956. Does it work? But it took us nearly 10 years to be like, hey, can we actually apply this for commercial uses? So there was also something happening in the 1960s that I think kind of helped lead us to this idea of using biology and development against the insects. And that was the human birth control pill became widely available. In 1968, a company called Zoecon, which is an agricultural research company at the time, actually developed the very first insect growth disruptor registered for use in the United States. And that was methoprene that was actually registered at that point. They were often called birth control for insects at the time. So in 1975, methoprene is officially registered as a mosquito larvicide and a cattle feed-through. In 1979, we have the very first ever application of an IGD as a crop protectant and against cigarette beetles in stored tobacco. Go forward another year from methoprene, 1976, diflubenzuron was registered, which is again another IGD. 1984, we get hydroprene. 1995, we get pyriproxyfen, and then 2001, we get novaluron registered as an IGD in the United States. IGDs really became commercially available in the 1980s here in the United States and are still heavily used today for management of all types of pest infestations. So methoprene was the very first commercial insect growth disruptor to be used to control mosquito larvae. Most of the other mosquito control tactics up to that point were either drain the water or utilize films such as oil or gas or some other kind of biological oil on the surface of the water to control mosquito larvae. Also, obviously, insecticides, but we're not talking about those today. Hydroprene was found to be volatile and extremely effective against cockroaches, so it can move in an environment. We found that pyroproxyfen can impact adult female tsetse flies, causing them to produce no viable offspring. Tsetse flies are a major vector of disease. And then novaluron is used to control termites and is also known to be effective at sandfly, housefly, mosquito control, and other insect control. So IGDs, as we move from the 1980s to modern times, have found to be useful to manage a wide variety of pests in a wide variety of situations. Everything from mosquito larvae in water to fly larvae in manure to cockroaches in a commercial kitchen. IGDs have been found to be useful. All right, so let's talk about some specific IGDs. So for the most part, in structural pest control, we use two different groups of IGDs, chitin synthesis inhibitors and juvenile hormone mimics. We don't really deal with the receptor agonist much in our business. These are the main two that we deal with. So the first one I'm going to talk about are the chitin synthesis inhibitors. How do chitin synthesis inhibitors work? Well, they interrupt the process of chitin production. So what does that mean? Chitin is an important component of the insect cuticle. This is what gives the cuticle its strength, its rigidity. The insect cuticle forms the exoskeleton. It lines the gut, the foregut and the hindgut. It lines the respiratory system, and it is an important part of many of the reproductive ducts and functions of insects. Chitin is very specific to arthropods, fungus, and protozoa. Chitin isn't really found in mammals, vertebrates, or higher plants, but it is effective on other arthropods. And I mention this because chitin synthesis inhibitors can affect things like crabs, lobster, what I call crawdads, crayfish, crawdaddies, I don't know what you colloquially call them, but anything that has an exoskeleton made of chitin can be affected by a chitin synthesis inhibitor. Obviously, fungus has chitin in their structures, so it can be affected by a chitin synthesis inhibitor as well. CSIs in pest management, common ones include novaluron. Novaluron is available as sprayable IGDs. It's available as granule products, and it's available as a compressed termite bait. Novaflumaron is available as a termite bait, and diflubenzuron is available as a cattle pour-on for lice control, and it's available as a feed-through for cattle for fly control as well. So as you can see, CSIs are pretty commonly used throughout the industry and very, very effective. So let's talk about chitin synthesis inhibitors and how they work. We usually think of chitin synthesis inhibitors as a larvicide or something that's effective on nymphs because chitin is something you have to build that next exoskeleton, right? Treated larvae will continue to develop normally until it's time to molt, and at which point they cannot shed their skin or molt properly because of the lack of a new exocuticle. Now, chitin synthesis inhibitors in general, the precise mode of action isn't 100% known because the production of chitin is such a complex biochemical process. We can't identify exactly where in that process chitin synthesis inhibitors work. Over here on the right, you see a cross-section of an insect integument, meaning their exoskeleton, the exterior part of their body. And you can see the different bits and parts. So you have a cincilla or a hair, you have nerve endings, you have the wax layer that's visible, the cement layer as part of the epicuticle, and then you can see the pore canal coming through. So all of these bits and pieces make up the entire insect integument. Now, CSIs and pest management. Why are they effective, and why do we use them? So for termites, termite workers are constantly molting, and they are the ones that are going to be most affected by the chitin synthesis inhibitors. So the more active a chitin synthesis inhibitor is, the more effective it will be as the termite workers are molting. Fleas, chitin synthesis inhibitors are effective because the first one is eggs just fail to hatch. There's some evidence that fleas have a little egg tooth that they use to escape the egg, and they can't harden that egg tooth to get out of the egg. And then also larvae can't molt properly. We'll talk more about that molting improperness here in a minute. Flies, there is reproductive inhibition for sure on adults, and we also know it inhibits molting in flies as well. So you can treat a substrate with something like a chitin synthesis inhibitor. Fly eggs that are trying to develop in there, the maggots might do quite well, but you won't ever get any adult flies coming out of that substrate, such as manure or other organic material. And then cockroaches, we know chitin synthesis inhibitors can cause a phenomenon known as an abortive molt. Now, this is always an interesting topic because I get to show you pictures of abortive molts. So what happens to cockroaches affected by a chitin synthesis inhibitor? These are an American cockroach on your left and a German cockroach on your right, affected by a chitin synthesis inhibitor. And as you can see, the insect is kind of halfway molted. It's been able to split open the back suture to try to crawl out of, but it doesn't have the strength to physically pull itself out of its old exoskeleton. And so you get what is known as an abortive molt. It actually dies during the molting process. We've shown this a number of times with chitin synthesis inhibitors in lab and field populations. So you actually get mortality with the application of a chitin synthesis inhibitor. So this is what's occurring with termites, with termite baits, with fly larvae, with cockroach nymphs, anything that's trying to complete the life cycle, flea larvae, that sort of thing. So let's talk a little bit now about juvenile hormone analogs and how they work. So juvenile hormone analogs mimic natural JH. So the insect maintains an unnaturally high level of juvenile hormone in their body. Now, if you think back to the function of juvenile hormone for an insect, it kind of tells the insect, hey, don't become an adult yet. So these insects maybe start the molting process, but they don't molt into the adult form. It's believed that juvenile hormone will actually bind, the juvenile hormone analogs will actually bind to the JH degrading enzymes or JH receptors so that they're just constantly available and the insect believes they're just being flooded with JH. It's most effective, it's applied to the insect at the beginning of metamorphosis. And remember, most of these IGDs have very little effect on adult insects. So that's true of the JHAs as well. Now, if you've ever used a juvenile hormone analog, such as pyriproxyfen on a cockroach, for example, you know that there can be dramatic consequences on the developing insect body. So if you have an instar that's treated, a late instar that's treated, you get some weird wing formation. For insects with complete metamorphosis, if eggs are treated, you can actually see formation of the embryo completely come to a stop. If it's applied to late instars, you get abnormal pupation or this weird combination adult pupae thing that happens. You can get sterilization of an insect that's trying to get to the adult stage, and you can get death. But with juvenile hormone analogs, timing and exposure to that juvenile hormone analog is very, very, very important. What are some things that juvenile hormone analogs are used for? So the first is fire ant bait. There's a number of fire ant products that contain juvenile hormone analogs, and it's believed that queens exposed to juvenile hormone analogs actually stop producing eggs. So when you start talking about colony level effects and crashing a colony, expose a queen to some juvenile hormone analog and she can't make any more eggs. This then shifts the caste makeup of the colony. So your worker caste just continues to get older and older and older and older, and there's no young ants to come in behind that group of older ants, and can greatly shift the makeup of the colony. Mosquitoes, juvenile hormone analogs have been used for years in water to stop larvae development. So larvae continue to develop normally, but when it gets to the pupal stage, they can't emerge from the pupal stage. They don't emerge. They get developmental abnormalities, and they just can't emerge from that pupal form. So they're still there to feed the fish, but they're not able to emerge into that adult biting stage. And then we've talked a little bit about cockroaches, but German cockroaches specifically, it's known that male cockroaches exposed to juvenile hormone analogs can have deformed adiagus or sex organs. Females can have deformed ovaries, and you get this general twisted, crinkled wing appearance, and cockroaches that are darker in color that are often a symptom of sterile adults. So this is an example of what I'm talking about. You have those very, very deformed wings in this German cockroach, and this insect, which is obviously very darker in color than a normal German cockroach. So you can see the forewings kind of curled up. It almost looks like scroll work. And then the hind wings completely shriveled up, barely going down, like maybe 2 or 3 segments on the abdomen. So this is a very affected German cockroach that would probably be sterile as well. So how do these things get used in pest management? So pyriproxyfen gets used as a sprayable, just mixed in with an adulticide or alone. It's common in mosquito dunks or other larvicides. It's common in cockroach and fly baits, aerosol products, and animal spot-ons. So imagine the thing you use on the back of your dog or your cat. Pyriproxyfen has been a part of that type of application. Hydroprene is also a very common juvenile hormone analog used in our business for sprayables, aerosols, and devices. If you're familiar with the little puck-style hydroprene device that's for sale in modern pest management. And then methoprene, it's used as a sprayable. You can find methoprene as an animal collar, mosquito dunks and larvicides, aerosols, and again, a fire ant bait. So you can see these products are used extensively throughout our industry and are very, very effective at managing population control of pest populations. So the next question is, are IGDs appropriate for bedbug control? Now, there's a lot of work on juvenile hormone analogs alone that you can go look up. I'm not really going to talk about that a lot today, but I will talk about a study from 2017 out of the University of Florida by Drs. Campbell, Kaler, and Rebecca Baldwin. And it was locomotion inhibition of bedbugs following topical sublethal doses of a chitin synthesis inhibitor, lufenuron. So this particular study was looking at CSIs for bedbugs. There weren't and aren't really many studies that have investigated this effectiveness. And there are really no current CSIs registered for bedbugs. The researchers at UF wanted to look at the lethal and sublethal effects of lufenuron to these 5th instar bedbugs. They looked at 2 strains, a Harlan strain and a field collected strain, and individual bugs were treated with lufenuron. Now, I want to make sure I'm clear. Lufenuron, chitin synthesis inhibitors, are not currently labeled for PMP use against bed bugs. So I want to make sure we're clear about that. This was data that was produced out of the University of Florida a few years ago. But as you can see, there was a particular number of affected bed bugs at some of the higher application rates of lufenuron. Unfortunately, it's difficult to get a lot of these products registered with the Environmental Protection Agency because of the thresholds they have of control. Unless you're hitting 90% control, they won't allow you to add a public health pest such as the bed bug onto a pesticide label. So if you look like, let's say, at what we consider a field collected or resistant strain, the Bradenton strain, at the 1.25% dose, you can see about 78% of the insects were affected. So I'm going to try to circle that right here. So you can see my mouse. About 73 to 78% were affected. And then that number dropped off when you got a little higher application rates. But there is hope of a CSI, a chitin synthesis inhibitor, affecting bed bugs. This is kind of what it looked like. So you remember those abortive molt pictures that I showed you with cockroaches? We saw some of the same things with bed bugs. So picture A is a fully molted adult that died shortly after emerging from their exuvia. B is a 5th instar bed bug that died during the process of molting, that abortive molt, also with an extrusion of internal stomach structures. And then picture C is a 5th instar bed bug that died during the molting process, not being able to fully emerge from its exoskeleton. So again, this is that abortive molt feature that we were talking about. So these insects would be affected by the chitin synthesis inhibitor. So in summary, these researchers showed that lufenuron did show molting effects and effects on locomotion, which we didn't really talk about today. But treated bugs really couldn't grip surfaces with their legs. They couldn't walk. They couldn't fold their legs properly. And it had significant effects on ecdysis. Higher doses were needed on the field collected strains, but there is some hope for chitin synthesis inhibitors for use against bed bugs in an integrated pest management program. So in another study that was unpublished by Drs. Campbell and Dr. Kaler, they looked at a late instar bed bugs exposed to a combination product that has pyroproxyfen, a juvenile hormone analog, and a chitin synthesis inhibitor, novaluron. So they treated tiles, allowed them to dry, and exposed those immature bugs to that treated surface for 1 hour. And what they found that after 14 days for the, I'm going to talk about the field collected strain, we had a 30% mortality with field collected bed bugs using Tekko Pro dried surfaces alone. And again, this is a combination IGD product. Again, I would like to point out Tekko Pro is not currently labeled for bed bugs, but we're just hoping to develop a product that might work on bed bugs to the level that the EPA expects in the future. So chitin synthesis inhibitors do show some promise versus bed bugs. Currently, I do not recommend the use of CSIs or JHAS for the control of bed bugs. IGDs for general pest management. So let's kind of move away from bed bugs and talk about some other pests. So one of my favorite pests to talk about with IGDs are fleas. So with fleas, we deal with something called a pupal window. This term was coined in 1991 by Dryden, and this is the phenomenon of when we go out, we do a flea job, we knock down and kill all the adult fleas that are bouncing around at the time, but then within a few hours or a couple of days, the pupae begin to emerge. They emerge because of CO2, just general heat and vibration, and your customer is very unhappy because they continue to have a massive flea problem after you've made an application. This continued emergence often leads to multiple, and often unnecessary pesticide applications. So with flea control, I highly recommend including an insect growth disruptor in your flea services. What does that do? So what we did is we treated some sand, carpet, and mattress ticking with a pyroproxyfen only and a novaluron and pyroproxyfen combo product, and then put eggs directly onto that surface to see what would happen. Larvae onto that surface to see what would happen. As you can see, we had 100% inhibition of adult emergence from those larvae compared to the controls, and then almost 100 with pyroproxyfen alone. So these are very effective products at stopping, I'm going to go back one slide, stopping that larval phase right in here from developing into a pupal phase. So you can manage these bottom two phases and this top phase with a single application of an adulticide to control the adult, and then an IGD to control the developing life stages down here. So then you really truly only have to deal with that 10% of the population that are already made it into the pupal form. So let's talk next about large cockroaches. Now, in my opinion, PMPs in general undervalue IGDs for management of large cockroaches. Why? Because American cockroaches, for example, Oriental cockroaches, even Turkestan cockroaches have really long lifespans. And because IGDs are slow acting, it's hard to observe the effect of that product over time. So how can IGDs impact an American cockroach population over time? So again, we looked at this combination product of a juvenile hormone analog and a chitin synthesis inhibitor to first and second instar American cockroaches exposed to a treated surface for 4 hours. So this was a treated and dried surface, exposed for 4 hours, and then we watched these first and second instar cockroaches for a full 12 months. And what I want to show you here is the mortality of these cockroaches as compared to the control that were exposed to the combination of a juvenile hormone product plus a chitin synthesis inhibitor. And as you can see, in the controls, we had about 8 plus live cockroaches and only 4 live cockroaches average per treatment. So out of all the replications that we did, about 85% made it into adulthood in the controls, and only about 40% made it in the combination IGD exposure only. So if you can imagine making an application into a place that they're exposed a single time in the first or second instar for 4 hours, you can start bringing that total population down over time. So don't sleep on IGDs for large cockroach control just because they're going to take time to affect the population. Use that integrated pest management tactic, entire program, including IGDs. Long-term control can be affected by using an IGD. The next thing I want to talk about can be a little controversial, and that is the use of IGDs or IGRs in backpack mosquito misting applications. So we were interested in this as well, and so we actually partnered with the City of New Orleans, the people who are hosting this webinar, and we used a couple of different combination products. One that contained one type of adulticide, pyrethroid, a chitin synthesis inhibitor, and a juvenile hormone analog, and then another one that contained a different pyrethroid, chitin synthesis inhibitor, juvenile hormone analog. We treated some just standard backyards in New Orleans at week 1 or week 0, really, and then monitored those yards for 17 weeks for population effects. So what we wanted to look at was how many eggs were being placed in the ovicups in those treated and untreated yards over that 17 weeks. Because again, that's going to be what might lead us to a definitive answer on, is there a benefit of adding an IGR in a perimeter spray, a backyard barrier spray? So this is what the City of New Orleans found for us. With the combination products that contain an adulticide and chitin synthesis inhibitor with a juvenile hormone, you can see we reduced the total number of eggs collected in those ovicups over the period of 17 weeks significantly, statistically significantly, compared to a control. So again, you're inhibiting population growth over time. So that was a benefit to me, and I do recommend including IGDs in backyard barrier misting sprays. So the summary for general pest control is that IGDs can impact populations of many insect pests, and what you get out of including that in your integrated pest management program is population reduction over time, even if you're dealing with very long-lived insects. Oops, went the wrong one. All right, so another question I commonly get about insect growth disruptors, especially as it relates to resistance, is have insects developed resistance to these types of chemistry? And the answer to that is yes, because that's what insects do. We definitely have evidence of crop and animal health related pests developing resistance to IGDs, whiteflies to pyroproxyfen, and houseflies to pyroproxyfen. This is probably related to proximity to crop applications that are occurring on a fairly regular basis. Yellow fever mosquitoes have shown moderate resistance to pyroproxyfen, primarily in California, again, probably due to some of those crop-related applications. Houseflies related to those crop-related applications as well. And then red and confused flower beetles, resistance to methoprene and hydroprene. So we know that this happens from time to time, but it hasn't occurred widespread throughout many of our urban pests. So let's talk about a few myths. Again, questions that I get regularly. One, all IGDs affects insects in the same way. Now, I hope you'd already know the answer to that from listening to me babble on for 48 minutes. And that answer to that is no. Depending on the type of IGD, what the active ingredient is, it's going to affect insect growth systems differently. So juvenile hormone analogs impacting juvenile hormone or mimicking juvenile hormone, or chitin synthesis inhibitors stopping the development of chitin. And the reason for me calling them IGDs in the first place is they do act very differently. Another myth is that IGDs can't be used alone, and I absolutely say this is false as well. IGDs can stand as a standalone insecticide. We use them all the time standalone. Think about a termite baiting system, but be prepared to be patient because it's going to take a little time for those population levels to drop. And it's also important to be sure you're not dealing with a resistant population if you're talking about houseflies, whiteflies, some of those other insects we talked about a moment ago. The next question I get, or myth, is that cockroaches affected by an IGD will not produce an ootheca. This is absolutely false. Cockroaches affected by IGDs can still produce ootheca, but often those ootheca are not viable. They'll be kind of shriveled up, discolored, just don't look right, JDLR, right? So you'll see that a lot with cockroach ootheca affected by these types of insects. So why should PMPs choose to use an insect growth disruptor? In my opinion, they're excellent for sensitive accounts. They're low toxicity to pets, to people, to children, to other animals. They're non-repellent, so they're an excellent addition to repellent and non-repellent already in place integrated pest management programs. Many of the IGDs have a really long residual for indoor applications, some as long as 6 months. There's some evidence that using an IGD can actually stimulate cockroaches to feed, which is increase improved baiting acceptance and increase feeding on those baits that we're placing out. You can also reduce the ability for pests to reproduce. So you're reducing population growth and keeping those populations at a level that is not considered pestilent. And then again, you're adding a different mode of action into your integrated pest management program. So I think there's a lot of benefits for adding IGDs into an IPM program. Then finally, with every rose comes a thorn. So when our IGDs unhelpful. So when should you consider not using an IGD? So my rule of thumb here is if the damaging stage of an insect is the larval form, avoid using a juvenile hormone analog alone. So the best example I could think of here was like a fabric or a carpet moth infestation, eating maybe a really beautiful Asian Oriental rug, or fur, or a mount. What do you call it? The mount, taxidermied animals. You can control the adults. Maybe you'll kill some of the larvae, but if you just affect the larvae with a juvenile hormone analog alone, you can extend that feeding stage and can increase damage of these insects before that reproductive cycle is interrupted. So if you are going to use an IGD in those situations, make sure maybe you're combining it with a chitin synthesis inhibitor and an adulticide. Another drawback of using IGDs, and we've kind of touched on this, is that results are typically delayed. This is not an adulticide that kills immediately, like those other kind of typical pesticides we were talking about earlier, the pyrethroids, the neonicotinoids, some of the other typical adulticides. Another thing is the insects are still going to be there. They're still going to be active. So if you're doing pest management and your client is expecting immediate effects, you're not going to see that with an IGD alone. And then finally, another thing that IGDs can cause is they can cause insects to behave abnormally. They are slow moving, they look weird, they act weird, they come out in the middle of the day, they're just not right. And that can be somewhat distressing to certain clients. So it's important to understand how these things work before you decide to use them alone. So to kind of sum up today's webinar, not all IGDs work in the same way. They have very different ways that they affect insect systems. IGDs affect normal growth and development of insects. They are not meant to be adulticides. IGDs, like other insecticides, must be used judiciously as a part of an IPM program, and not all IGDs are effective on all pests. So carefully choose which IGD you are picking for the pest and the site you want to work in. So how do you choose the right one? Number one, read the label. If the pest you're targeting and the site you're targeting are on the label, you're good to go. If you're using a juvenile hormone analog, ask yourself, will prolonging the immature life stage help or hurt me as a pest management professional? And then finally, what benefits does using this bring to the overall integrated pest management program? So with that, I will say thank you. Thank you for taking your time with me today. And I'd be happy to answer any questions in the very short amount of time we have left.
Okay, I'm checking the chat. I don't see any questions here right now, but I'm gonna give people just a second to type because I saw someone with their hand raised. Okay, we have a question. I'm gonna unmute someone. 1 second. You can unmute yourself now to ask your question.
Hi, this is Deanie Miller. And thank you very much for your presentation. I wanted to ask, hey, how are you doing, Janis? I wanted to ask because I'm working in public housing again, as usual. And one of the things we typically see are the Gentrol point sources, about 17 of them that have been collected underneath the stove or the refrigerator, where the pest control operator over time has put one in every quarter and they've just all stayed there. Now, supposedly, the it's methoprene or hydroprene they have in there is supposed to move out and away from those point sources and actually cover greater distances, but I'm not really seeing any evidence of that anymore. And especially with the accumulation of the number of point sources that we'll see under these appliances that haven't been moved for ages, I just wonder, is that IGR all sitting there? And it makes me curious as to whether some of these German cockroach populations may have resistance for exposure because of exposure to sub-lethal, sub-effective doses over time. What are your thoughts on that?
So I can't speak directly to that particular product, but I can talk about the active ingredient in general, so hydroprene.
Mhm.
If you have a population of insects, and Deanie, you know this as well as anyone, if you have a population of insects that's constantly exposed to a low dose of an insecticide, you're certainly more likely to develop resistance over time. So if there are, I think you said 17 of them underneath a cabinet, and they've been there for, you know, months and months and months and months, there's certainly the possibility of a buildup of resistance in that population. I know that one of those devices is meant to treat up to about 75 square feet. So, you know, if I think about an average public housing that I've been involved with, you know, your average apartment is probably 800 square feet. So, you know, you could potentially use 10 of those point sources in a single area. And again, this is what I'm remembering from using these products in the past, so please do not quote me on any of this. But what I do not remember is how long it says you have to replace them. Again, this is like strictly going from my memory, I think you're supposed to replace them every 3 months, every quarter, basically, is the way they were designed. So
That's what they're doing.
every quarter, okay.
Mhm.
I would be very interested from a lab standpoint to expose those cockroaches directly to hydroprene in a controlled environment that they can't move in and out of, and see what happens, because that seems to me like there could definitely be some resistance has built up in those populations.
Yeah, because they're being put out, new ones are being put out every quarter, but none of the old ones are ever taken away. So
Do you remember
there's
the old
still-
bait pucks that people used to use, and you'd find them everywhere?
Yeah, it's kind of the same thing, because they're all put under this appliance and then nobody moves the appliance, so they just sit there forever. Okay, thank you.
I also know hydroprene is heavier than air, so it actually moves downward. So maybe check the apartment below that one.
Interesting. Interesting idea.
It's good talking to you, Deanie.
Yeah, nice talking to you.
Okay, I don't see any other questions in the chat, Dr. Reed, but I just want to thank you for joining us again today. And everyone else, have a great afternoon. And thank you for coming out to our webinar.
Bye.
Thank you. Great job, Janis. Awesome.
Thank you.
Not,
Have a
very
great day.
topic too.